Thank you. Double the applause. How lucky I am. Thank you, everyone. Welcome. In the next 40 minutes or so, we're going to discuss how we can effectively deploy Java applications into production with containers. Before jumping into the technical slides, I want to start first with a quick poll. How many of you are actually using containers? A large audience. Awesome. How many of you are deploying Java or JVM applications in containers? Perfect. How many of you use orchestration tools such as Kubernetes, Docker Swarm? Good. Big audience. And how many of you believe that containers were actually a mistake? Few hands. Yeah, we can have a coffee afterward and discuss that. So, quick intro, Mohammed, work at Spotify as a backend engineer. And if you want to chat afterwards, please let's grab a coffee. Otherwise, I'm pretty active on Twitter. If you want to discuss anything related to containers, Java, cloud native, anything in between, I'll be more happy to do that. My Twitter handle is Laytune. And in this talk, we're going to talk about this man. His name is called Pharaoh, and we're going to see his journey, how he started from learning about containers till deploying them into production. And Pharaoh is an avid Java developer who has been working with Java for the past 20 years or so. He truly believes in the power and limit of code. And as any one of us who has been working in the IT industry in the past 20 years, 10 years, whatever, he heard a lot about containers and all the goodness it offers. And he starts asking himself, should I use it? So this talk today will basically highlight his story, starting with somehow the philosophical question. Should I actually use containers? Is it a good idea? We will see afterward how we can create effective Docker Java images that are both faster, smaller, and secure. We will see some tools and libraries that make working with Java and Docker a lot more easier and hopefully more fun. And we will see the things that we should know and the things that we should avoid before putting a Java application into production. And finally, we will see all the features that has been added to Java, and believe me, it's going to be a lot, to make the Java or the JVM more container aware. So we all know in this room that containers are nowadays everywhere. And they have been used for a wide range of applications. You can use them for your old monolith application, or you can start using even the smallest, fast, serverless, whatever they're called nowadays. And that's because they offer a great number of benefits. They enable easy deployment. Now, don't get me wrong, once you set up your cluster, it becomes easy. Before that is a headache. But still, they offer easy deployment, offer easy scaling, and even beyond that to automatic auto-scaling if you get that right. Once you define your metrics, your cluster can scale and answer the demand of the load. Containers advocate for the use of decoupled infrastructure or decoupled services, what we call microservices. And it also advocates for the use of immutable infrastructure. And in immutable infrastructure, once an artifact is created, it cannot be modified via the user data. And it goes beyond that. And containers and Kubernetes, and even in the cloud native world, everything is declarative, meaning that you declare your intention in a file, YAML file generally, and by the way, I hate YAML. And the management layer basically take care of applying your intentions and make them a reality into the cluster. You all probably know that one of the great benefits of using containers is efficient resources utilization, since you condense all your services or your containers in the same VM rather than on the same cluster, whatever, rather than one VM, which consumes a lot of resources. And one of the big points of the containers community and the cloud native community in general is it has a rich ecosystem. You would find help, you will find support, you will find tools that enable you to do pretty anything you want to do. And the backbone behind containers, going a little bit backward now, is two things: namespaces and C groups. So very briefly, namespaces are basically used for providing different isolated view on the system. So each process will have its own view of things like process ID, network ID, user ID, and so on and so forth. C groups, on the other hand, is a mechanism that enables us to perform limiting and metering for the resources that can be used by a process. So, and by resources, I mean like CPU, memory, block I/O, network I/O, and so on and so forth. So in C groups, each subsystem, and by subsystem I mean CPU, memory, and the things I mentioned, forms a tree structure or a hierarchy of nodes, and each node and each subsystem belongs to one node and one node only in this hierarchy. So given a process, it will belong to one node for CPU, one node for memory, one node for block I/O. You get the idea. However, when the system boot, there is actually one node, what we call the root node, right? And the first processes that spin up when the system boot belongs actually to this node, right? So if you think about it, even if you are not using containers yet, for the few people that are in the room, you're actually using a container because there is already the root container that you are using. Moving on. Fero, our friend, started asking himself, is it actually a good idea to use a Java application inside a container, especially that the JVM offers a great number of features by itself. The JVM has also a great and rich ecosystem, great community as well. I'm biased because I'm part of it, but yeah, nevertheless. The JVM is also battle tested from a security point of view, since there are a lot of companies, a lot of developers out there that are running mission critical applications on the JVM. And also, and this is one of the great features of the JVM, it is hardware and OS agnostic, and it's runtime adaptive. And by that I mean the JVM, whenever you try to deploy it, it will try to tune itself and adapt itself to ensure the best performance in the execution environment. However, our friend Fero decided to give it a try, and probably he was getting a lot of stress from his manager. So he came up with this nice Docker file. Now, this is not the great Docker file that you will find out there, but you get the idea. For a beginner, it's fine. He built it, he ran it, the application is working fine. And then Fero started asking himself, what are the characteristics actually that my application and my container should have in order to be production ready? And the answer is three basic things. We need a good base image that contains our runtime dependencies. We need our container image to be as small as possible, and we'll explain why. And we need our container and our application to have a fast startup. So first thing first, when we talk about a good base image in the context of Java or JVM applications, we talk about the JVM itself, right? Now, in the past couple of years, there were a lot of discussion about Java and its ecosystem, especially after the new release cadence. It's no longer new, but back in the time, it was a lot of stress about the new release cadence. It's become now 6 months, and you have a new Java version. It's six months. I can't believe that, but yeah, we're there. And it actually worked really well. And Oracle, back in the days, a couple of years ago, changed the licensing model, which drive people a little bit crazy. But as I mentioned before, Java has a rich and vibrant community and ecosystem. So there are a lot of options out there that offers OpenJDK distribution for free. You can grab it and use it. And even if you need support, there are many companies that are willing to provide you with that as well. And as Dr. Venkat Subramaniam says, there is no such thing as end of life if you have enough money. So as far as your company is willing to spend money on some old versions of Java, Java 5, 6, whatever, even Java 8 is now considered an old one. But yeah, you got the idea. The second thing is to optimize the image size. And for that, there are a couple of things that we can follow both from the Java side and from the Docker side. So from the Java side, in Java 9, there is a project that was introduced called Jigsaw, or Java Modularity. And what this project enables us to do is basically to tailor the JVM and select only the modules that we need during runtime. We can even go beyond that and build our own custom GRE, putting the GVM in a strict type. Also, techniques like code refactoring and code reviews can enable us to reduce the size of our code by, if we're using a whole dependency for a small utility function, you can get rid of that and do some refactoring and use it and get rid of the dependency. That will save you some nice kilobytes. And finally, talking about the dependencies, there are some tools like gdeps that enable you to check the tools that the libraries that you are using and what not you are using. Make sure to remove the dependencies that you are not using, because that's a headache, both from a security point of view and from a size point of view, in case you want to use containers. From the Docker side, using a smaller base image is a good idea. The smaller your base image is, the smaller your final image will be. Also, understanding the concepts of layers and caching of Docker helps to reduce the size of your image. And as a general rule, try to combine the related comments in your Docker file and separate the unrelated comments. There's a balance between the image size and readability of your Docker file, and getting that balance right is really important. Also, cleaning up right away. And generally, when working with containers and creating our Docker file, we tend to download an archive, do whatever we want to do with it, extract it, and then forget about this Docker file inside our image. So removing those kind of packages once you are done with it helps to reduce the image size. Also, understanding the build context and using Docker ignore, depending on your application, your business logic, you may want to not include some folders when you are building your image. Things like the Git directory, the .git, or some log directories. You don't need that during build process. You don't need them in your production image. So using Docker ignore to ignore, it's pretty similar that Git ignore. They will not be sent to the build context, which are basically the files that are sent from the Docker CLI to the Docker daemon in order to build your image. And a nice side effect of using Docker ignore is you're going to speed up the build process, since as I mentioned, the build context is smaller. Also, using multi-stage build. This is a nice feature of Docker, introduced it years ago, and it enables you to separate your build stage or stages from your production stage. So if you're a Java developer, you will have you build your image, do whatever you do, generate your artifact, and then have a clean production image. And this final image will be a lot smaller. Another decision that you need to make, depending on your application, is to download or include your config file, whatever files you want to need, your application need for configuration during build time, or postpone them until runtime. There is no right or wrong decision. It depends heavily on the context, on the business context. But postponing them until runtime comes with its own challenges, but it helps to reduce the image size. Having them in build time is, of course, a lot more faster, a lot more easier, but it impacts the size of your image. So there is a trade-off that you need to keep in mind. And finally, user tools such as Docker Squash and Docker Slim enables to squash your image, reduce the number of layers it has, while making sure that the final image is just like behave the same as your image, your initial image. And while talking about the image size, you probably heard already of Alpine. How many of you know about Alpine? Cool, a lot of people. So Alpine is basically, and very briefly, a lightweight Linux distribution used mainly for containers, or it's gained a lot of popularity in the container world. And it's based on muscle libc and BusyBox. Very briefly, BusyBox combines multiple versions of common Unix utilities into one single executable. That's why it's really fast and really small. And muscle libc is the implementation of libc as the standard C library, and it's basically the standardized interface between the userland and the kernel, doing such things like opening files, managing the networks, and so on and so forth. However, there is one not small, but critical difference between Alpine and other Linux distributions that we are familiar with. Debian, Ubuntu, whatever, Red Hat, is the muscle libc. Those other Linux distributions use actually glibc. So a C or C++ code that is actually compiled with muscle libc will not work on glibc. It needs to be, most of the time, recompiled, and vice versa. And you may be wondering why a Java developer mentioning C and C++ code in the middle of a Java talk, and that's because we, as Java developers, are using a critical piece of software engineering that is written in C++, which is the JVM itself. So in order to ensure a transparent run of the JVM in Alpine, we need to port the JVM into muscle libc. There are some code changes that needs to be made. And luckily, such projects exist. It called it Project Portola. It took a long time for this project to get merged to the JDK itself and become available. But before, you may be, for the people that have been using containers in Java before, you may have seen, a lot of images, mainly from the OpenJDK or Adopt OpenJDK images that are using Alpine with Java. And what they have been doing, basically, is adding the glibc Alpine package on top of Alpine, just to make sure that the JVM is running on glibc and not muscle libc. And the size is still much more smaller than using other images from Linux distributions, such as Ubuntu or whatever. And in Java 16, Portola got merged. So the JVM finally is ported to Alpine. If I did this talk 2 years before, 2019, 2020, it wasn't the case. But I think in 2021, late 2021, the Project Portola got merged, which is cool. And this graph gives a nice overview of the size of your Docker images. It's up until Java 11. And you can clearly see that the winner is by far Java 8 Alpine image, followed by another image, which is, okay, I'm far away from the microphone, which is a distroless container image. I don't know if you have seen it, but it's, yeah, one of the smallest ones. And it comes from GCR, and GCR stands for Google Container Registry. And this distroless container image is actually a cool project from Google. And it's an open source. It tries to provide container images that are actually stripped down and contain only your application and its runtime dependencies, restriction what's inside your image to only what your application needs to perform its function. They are really small and really good, and they are basically glibc based, which is a good alternative if you don't like muscle. They don't contain a lot of the things that we are familiar with in a normal Linux distribution, such as shell, managed packages. All that is removed. It contains only what your application needs to execute, basically. Those images are built using Google Bazel tool. They provide very small images, and they support multiple languages. So give it a try, even if you are not a Java developer or use Java in your day-to-day work. And someone would say, why should I care about making my image smaller, right? I mean, if it does work, it works, and call it a day. And the answer is three main things. Each thing in your container is something that the provenance needs to be tracked and needs to be scanned for vulnerabilities. So you need, that's from a security point of view, you need to care about what's inside your container. Each time you are pushing and pulling your container, or your image, sorry, you are incurring costs in terms of data transfer and time. And time is the most precious thing that a human being, especially a developer, has. So treat it wisely. And finally, as I mentioned before, the smaller your image is, the smaller components it has, the smaller the surface attack. Theoretically, you are much more safer if the components that you have are fewer. And finally, or the third thing that we need to care about before pushing our application into production is actually having a fast startup. And There are a couple of things that we can do to achieve that, starting by using the latest version of Java, at least Java 11, because each version comes with a lot of optimization and a lot of improvements from a startup time point of view to reduce the warm-up period, which is really good. If you can migrate, move to the latest version of Java, please do. There is also class data sharing. And before executing your code or your application, the JVM does a lot of things. So given a class name, it looks up for the class name in the bytecode, closed it, it loads it, verifies the bytecode, and then execute and put it into an internal data structure, right? And the thing is, if the jar doesn't change, and it's generally the case in containers, as we are constantly rebooting and restarting our container, this data is exactly the same. This data, the JVM needs to do the same exact preparatory step each and every time to get to the exact same result at the end. And here comes class data sharing. And the idea here is to do this operation once, dump the load, the data generated into an archive, and then reuse it for future launches. And that will enable to reduce what we call the warm-up period. Ahead of time compilation. How many of you are familiar with just-in-time compilation or JIT compilation? A couple of hands. Good. So JIT compilation is basically the JVM, while running, the JVM analyzes your code. It's constantly analyzing your code and compiling the most executed code path into your native code. And that enables the JVM to improve the performance and execute your application a lot more faster. However, this JIT compilation during startup, we don't benefit from that since the code is not yet JIT compiled because it needs to be running and needs to collect profiling information about your application, right? So the idea behind ahead of time compilation is basically to combine your Java code into native code ahead of time so we can have a faster startup and reduce what we call the warm-up period. The first try to do that was with what we call GAUTC, with ahead of time compilation. It failed miserably. The developer experience was so bad, and it was removed in Java 17. And it got replaced by a cool project from, thank you, a cool project from GraalVM, or Oracle Labs, called it GraalVM. And GraalVM, the big one, is a universal virtual machine for a lot of languages, JavaScript, Python, a lot of things. But what excites the Java developers is actually a sub-project from that, what's called Substrate VM. And what it does is basically ahead of time compilation. Check your code, Java code, compile it into a native binary. So in the end, you have a binary file that you can execute without the need of the JVM. And that's improved hugely the startup time of your application. And finally, Crack. A Crack is a new experimental project. It's still experimental. Don't use it in production. Just play with it before. But the idea is really good. Crack is, the idea came from the Azul system, which is one of the OpenJDK provider. And the idea here is to take snapshots, the same as we do previously with the VM. Take snapshot of your running application that is warmed up, previously executed, JIT compiled, and then save it somewhere. And then next time you want to start your application, you are not going to start it the usual way, Java, something from your jar or your main class. You're actually going to execute the Crack or the checkpoint or the snapshot. So your application is actually already running. It will start from the previous state you took the snapshot, which improves the startup time heavily. Okay, mirror display, beautiful. Going quickly into what we discussed here. So I have this it's out there in GitHub, having some code, and we're gonna go quickly over what I mentioned for both optimizing the image size and also optimizing the startup time. I have a very simple niche application. So basically, I start a server, and whenever I receive a request, I print hello world. It's very damp hello world application, nothing fancy about it. However, I have multiple branches. Alpine, go up, go down. Alpine, crack, CDS, for all the things that I mentioned before. And I have a Docker file with each branch. And the master branch is basically running the application in a Java version, just to compare with no optimization what we get. Increase the font size. Let me see if I have any chance. No. How I can do that? Why is it not working? Wait a minute. I can do it, actually. Projects, no, not projects. Talks. Projects, talks, Java and Docker. No, I will stop here. Yeah, Java and Docker, that works. Good. How about that? Better? Bit more? That's too much for my little screen. I want to be able to follow. But let me see. Better? Cool. Awesome. Thank you. So moving on. How I can get my project view back then? OK, cool. Yeah, what I want to do is, so how about if we talk about Java modularity? I think it's called modularity. Get checkout mode. Yeah. Docker file? No. Get. Don't do that. Never. OK. So what I'm doing here, basically playing a little bit with Project Alpine, which, as I mentioned before, you can create your own custom GRE. Let me close that one. This is really annoying. So what I'm doing, I'm creating with G-Link my own custom GRE that contains only what I need. As you can see here, I need the base module, I need the login module, I need some other modules, and then what I'm doing here is I am taking my own custom GRE, call it the nature runtime. That's all what I need. The image size is really, really small. Since I'm running out of time, going to the other thing, which is it's class data sharing, maybe. Yeah. So in class data sharing, it went through a lot of improvements. So before Java 13, you needed to have a list class with all of the things that you need to dump. Let me go if I check if I can get it. Where is it? Anyways, because I remove it. OK, makes sense. So you needed to generate a list of all the classes that you want to dump, and then dump it, and then reuse it afterward. In Java 13, they made the process a lot more easier. So you can start your application with this option, archive classes at exit. So once your application exits, it will dump the files that it generated during runtime. And then in your build stage, you will enable the class data sharing user xshare on, and you will specify the archive file. So that way, you optimize for the next run of your application. I'm going to skip the ahead of time compilation, GUETC, or yeah, but we can have a look. It's really AOT. It was really bad. We used the GUETC command, and you needed to provide a lot of things before you need this config file to describe all the files that you wanna compile into native code using GUETC. And then it will generate basically a native binary that you can use afterward. And in production image, you're going to use this option, AOT library, basically specifying your native binary code that you ahead of time compiled, and it will help to reduce the image size of your image. It has been removed, as I mentioned, in Java 17. You don't need to worry about it. But what you probably want to do afterward is checking out Graal. And you would need Graal. You would need to compile the image or the native image utility. As I mentioned, it's a project. It will basically, using the native image, compile your application into a binary, right? And look at this. Isn't it beautiful? It's actually a Java application running on Scratch, nothing in there, pretty empty. It's like a desert. And then using my native binary that I'm going to use. And that's it. Pretty magic. You can't imagine that running a Java application would look like that when Java has already started. Did I cover this all? I think so. Going back to master. So running this, I have a small benchmarking script here that basically run the application and then exit immediately just to measure the startup time and also the size of the image. Running this script, since I am running out of time, will generate something like this, like this one. You will have two outputs, the size and the startup. And you can see that the size between the plain image and the modularity using Jigsaw, I gained almost 10x in the image size. From 300, I want to only less than 60. From the startup time, you can see that using CDS helped to reduce a little bit the startup time, but with Graal, 3 milliseconds. That's crazy. OK, that was a quick demo around those capabilities. Moving on. Good. That was the demo. And then containers changed the way we develop, architect, and deploy our applications. You probably are aware of that. And they become what we call the executables of the cloud, right? Whenever you think about cloud-native applications, you think instantly about containers. And if you think about it, containers push it the WORA principle, write once, run anywhere, push it a little bit further to the PODA principle, which is package once, run anywhere. However, Ferro was asking himself, why can't I use the same old tools that I'm using as a Java developer? Maven, Gradle, all those great tools. I mean, they work. Generate the same, this new unit of deployment, which is containers. And luckily, such tools exist in both Maven and Gradle. So in Maven, the easiest way to achieve that is using Maven exec plugin, basically invoking Docker CLI comments from Maven. This solution is not elegant at all. It's so hacky, but just for your information, you know it exists. Another plugin, which is Docker Maven file from Spotify, Maven plugin from Spotify. It does basically two things. To build your Docker image, and then it deploy it, publish it into a registry. Nothing much. However, the Fabric 8 Maven plugin does a lot of things, both from container image, to build your image, publish it, and also from a container image, start the container, stop the container, and attach volumes, and so on and so forth. If you're a Gradle fanboy, yeah, same thing exists in Gradle. Another open source plugin worth mentioning is Jip. And Jip is an open source Java plugin that is available in both Maven and Gradle. It's daemon-less. It enables us to build container image without the need of a Docker file, and also without the need of having Docker desktop inside of our machine. This is the great magic. And what Jip basically do is something similar to what in this Docker file. So it splits our application into multiple layers, multiple packages, pushing the files that are less likely to change on the top, and the files that are more likely to change on the bottom, right? And this is great from a build perspective, especially an incremental build, because if you're a developer, you are more likely going to change your class files, right? Less likely your resources files, and even less likely your dependencies. So that will help to increase or make your build process a lot faster using Jip. Another good project is BuildKit, and BuildKit is basically meant to be the next backend implementation for Docker build command. I think it's already the case. And it offers a great number of benefits like concurrent build graph that run comments in parallel in order to speed up the build process. It keeps track of the modified files, so it doesn't need to load them. But for Java developers, it extends the run command with the -- mount. That doesn't exist in the normal Docker file, right? It's an experimental option. And you can mount actually your local Maven repository with your the build process with the image that is running, or to build the image that you're going to build. And that way, you are not in need to download the internet each time you're going to build your Docker image, right? And it kept in sync with your local repository. So you are helping the world, making it, saving the environment, because you are downloading less dependencies from the internet, and you are speeding up the build process. Another practice is image versioning. I will go a little bit faster because there's a demo that I want to run, and I still only have 5 minutes. Image versioning, there are a couple of practices that you're going to do, depending on what you are comfortable with, please do. And just avoid using latest to tagging, latest only to tagging your images, because it's not dynamic, not descriptive, and easily overridden. From a security point of view, this needs a talk on its own, but very quickly, start by knowing what's inside your container, especially if you're using a third-party provider base image. You need to make sure that those parties, those images, those dependencies are not downloading anything during runtime. Vulnerability scanning tools, constantly scanning your images against common vulnerabilities to avoid being hacked. Image sign-in and using Docker Content Trust. And when using Docker Content Trust, what it does basically is when you try to push the image, the Docker engine will automatically sign the image with the publisher private key. So when another user wants to push or pull the image, the Docker engine will automatically verify the image using the publisher public key. So that way, you are sure that Docker engine verifies the authenticity and the integrity of your Docker image, and making sure that it's the same one that the publisher published and not one modified via a malicious user. Using things like the least privilege principle, and in the context of containers, that means making sure that your application is run with the minimum set of access rights and resources that can be used by your application. And there are a couple of things that we can do to achieve that. Making sure that your application is not running as root. So even if an attacker manages to sneak in, we are not giving him a root access. Depending on your service, the needs, if it doesn't need, I still have another 5 minutes, right? Yeah. So depending on your application, you might want to have remove the write access from your application and keep it only read-only, right? So even if an attacker manages to sneak in, it's still fairly limited on the damage he can do, like injecting malicious scripts or modifying the data, or even worse, deleting the data. And finally, limiting the resources that can be used by your process so that you can avoid some kind of trouble, some kind of attacks like DDoS attacks. I mentioned this before, using a minimal container OS helps reduce the attack, especially the attack surface. And finally, having monitoring and auditing tools in place help to detect unusual behavior and trigger alerts. Integration tests. They're really hard to get right. They're really hard to make, right? Because we know applications needs to call other services, need to call databases, a lot of things. It's even more harder when distributed systems. It's a pain in the neck, basically, right? Test containers make this a little bit more easier. How many of you know test containers? Cool. For the others, you have to check it out. It's pretty cool library. It enables to spin up whatever a dependency you want to need. It's a Java library that supports many testing frameworks already that you are familiar with, like JUnit and stuff. It provides lightweight throwaway instances of almost all the databases, or at least the well-used one, most used. And yeah, very easy to use, and it provides a nice Java API to speed up instances and dependencies. So with that, Faro decided to go to production with his image. And what I'm going to do, I'm going quickly switch to my terminal. And I have, let me do that quickly. I have git checkout, I hope I got the name right, is B. I have a Spring Boot application running with two different Java images. The first one is Java 8. The other one is Java 17, right? Same thing running in both images. Nothing magical here. Probably I need to increase this one and increase this one, right? So what I'm going to do is I'm going to run my application using Java 8. Okay, without, where are you? Oh, God. So Docker, I'm going to run the application, run, expose it in port 8080, just for you to see that it's working. And then I think it's called isbg8. Is that right? I'm getting that right? Yes, cool. Right, running the application. Hopefully it starts fast. And yes, I hope it's running. So if I go to localhost 8080, you can see the application is running, right? We mentioned this before, that one of the great benefits of using container is resources limitation, right? So what would happen if I add a memory constraint here? So let's say 250 megs, right? And let's give it a name. Name SPG or SP8. Okay with that? Let's run the application and see what would happen. No? That's name, sorry. So you see, the first thing is the application is still using 2 gigs of memory, almost. That's weird, but yeah, you see that? Application is starting a little bit more slower, but then it fails to start. Anyone experienced this behavior before? One gentleman back there. Okay, what happened is, if we go to Docker inspect, Docker inspect, I hope I can find it. So if we hit Docker inspect, okay, yeah, what name did I give to the container? SP8 only? SPJ8, that one? Only SP8, right? Okay, thank you. You can see here that it failed with the error out of memory killed. And what happened is our image, or our container, our Java application, was using more memory than it allowed to use. It used 250 megs of memory. So the Docker daemon basically noticed that and killed it. So we are developers, and we will have a memory issue. What we do, we increase the memory, right? It's Docker run. Docker run. Okay, let's do the same thing. Yeah, okay. Docker run, let's make this one 500. Nah, this one. 500, and make this one 500 megs, right? How many of you think this one will work? One will not work. Another few hands. It actually, I hope so, it did work. The application will start. And to understand what's happened, I hope I can get it right. I still have it in my history somewhere. Docker exec R, no, not this one. Yeah, Docker exec R exec. I'm going to get there, bear with me, this one. How many of you are familiar with the GCMD, G command? It's basically called the GVM to get some provided information about the memory, CPU, and a lot of stuff. And this is basically querying the GCMD, basically querying the native memory, and making the scale of megabytes. Noticing anything weird here? The application is using almost 1 gig. 900 megabytes, right? Why is that? Any hints? Our application is actually swapping. It is using swap. So to confirm that, we are going to add swap. I don't need the name for this one, I think. I hope the swap memory, please, God help me. Swap memory, and I put in the same amount as the other one, which is 500 megs. So the application will actually have swap memory, unknown flag. It should be swap memory. Hello. Okay, S. Swap memory 500 megs, and then SBGH. Nah. Okay. Swap. If or yeah, should be this one, right? Memory swap. Okay, got it wrong. How many of you now think that the application will start? One. A couple of hands. Yeah, it does not. No, it finished before I finished. So that's the problem with previous images of Java. It's basically not container aware. However, if we run the same image, even with it's BG11, even with the 500s, only with 250 megs, right? You would see that the application is already container aware, that it has only 200 megs, and it exits already. Very quickly, can I have another 2 minutes? Thank you. Just to finish what I started. There are a lot of reasons why, and the first one comes from history. Docker appeared in 2013, Java 7 already out in 2014, and the work on Java 8 already started. So Java was not container and didn't care about Docker very much and containers back in the days. The other one is the JVM ergonomics, the thing I mentioned before. The JVM is a complex piece of software engineering, and it's runtime agnostic. It means that it tries to provide the best performance depending on the runtime it is running on. And it does that by collecting a number of metrics from the underlying host, the memory, CPU, and a lot of information. However, if it gets those information wrong or from the wrong place, this nice feature turns out to be a disaster. And this is what happened with the demo that we had. Java 8 got the information from the underlying host, didn't care about the cgroups limitation, and configured wrongly the heap memory. And the same thing applies for the CPU as well. If you're using Java 8 100 or before, 121 or before, there's no way the JVM is container aware. And good luck with that. There is a nice hack from the Fabric 8 community that's basically add a startup script that gives those information from the cgroups limitation and provide it to the JVM during startup. Java 9, we started having experimental options to provide support of the JVM and containers. Java 9, this is when the real stuff happened. Those are the metrics or the, what we call options that enable more fine-grained control over the memory and CPU you're going to use. And this is basically over the years, over the Java version, we started adding a lot of options to make the JVM more container aware, and we're still working on that. Monitoring, no system needs to go to production without monitoring tools in place. We can have a discussion for that later. No need for the takeaways because I'm usually out of time. Thank you.
Thank you, Mohammed.